So here we got a word problem. We got a river. I'll draw a picture. We're going 10 kilometers upstream, and then 10 kilometers back downstream. It's saying that the speed is 5 kilometers per hour more on the way back rather than on the way there. So first of all, you need to know how the formula for speed, distance, and time works. And what I find is the easiest to remember that is if someone says to you, how fast are you going when you're driving, what do you say? 10 kilometers per hour, or you say, I'm going 50 kilometers per hour. So, and per hour is like dividing. Kilometers per hour is like dividing. If you can say a speed, you can write the formula. Speed is distance, because that's your kilometers, divided by time. Now once you have that formula, and you say any speed, and the formula will just come to you, then you can rearrange that formula. If you want to get time by itself, what would I have to do? I'd have to multiply both sides by time, and then divide both sides by speed. So then you can get a formula for time. Time is equal to distance divided by speed. If you want to get distance by itself, distance is the same as speed times time. Let's see, how did some teachers sometimes do something like this. Have you ever seen a triangle thing? Where all you do is put your thumb over one of them. What's the formula for speed? Distance divided by time. What's the formula for distance? Speed times time. Time is distance divided by speed. So there's that as well. But if you remember what speed is to get a formula to start, you can just rearrange things to find the other ones. Now, because this question is dealing with speeds and time, okay, we want to write an expression for the total time it's going to take to go upstream 10 kilometers and downstream. But we don't know what the speed is. So what we're going to do is we're going to introduce a variable. We're going to say that his speed upstream was x, because we don't know how fast he's going. But we now know that his speed downstream is 5 kilometers faster, will be x plus 5. So if his speed upstream is x, his speed downstream would be x plus 5. We know the distance he travels both times. His distance is 10 both times. So if we're going to write an expression for the total time, does it make sense that that would be the time it took to go upstream plus the time it takes to go back downstream? And we already rearranged things that we have a formula for time. Time is just the distance divided by the speed. Well, first he goes upstream. How long is it going to take him? The distance is 10. The speed is x. Now he goes back downstream. The distance is still 10, but now the speed is 5 faster. So we get an expression that we're adding two rational expressions. So if we wanted to write a simplified version of this, we would need a common denominator. The first one's missing, x plus 5. The second one's missing, x. And our total time, now we have a common denominator of x times x plus 5. We're going to get 10x plus 50 plus another 10x, which will be 20x plus 50. So only question number 11 deals with word problems like this with time, distance, and speed.